Hello, this is Guillermo Campitelli, and in this series of videos I'm going to explain or apply the 7 approaches to cases in which there is we want to study the effect of a nominal variable on a numerical variable. And this is more traditional analysis in the case of if the nominal variable has only 2 values, we typically do a t-test, and if the nominal variable has more than 2 values, then we use a one-way ANOVA. We are going to see between subjects designs and within subjects designs, and so but we are going to do we're going to see the traditional analysis, but you are going to see the different analysis that we've been seeing in the previous videos. So let's start with the case study, and in this case study we are going to, this is the causal model, and we are going to investigate the effect of exposure to short films to the level of happiness. The model tells us that it predicts an effect of exposure to films to happiness, but happiness is not caused only by the exposure to short films, but there are unknown variables or unmeasured variables that we don't know of, and that also affect happiness. So we don't expect exposure to short films to explain the whole variability of happiness. Okay, let's start with the between subjects design, and in this case study that I explained, we've got 400 participants. The independent variable is exposure to 5-minute documentaries, and because I'm using 5-minute documentaries as an operationalization, I'm going to call this variable documentary from now on, instead of exposure to 5-minute documentaries. So there are 4 documentaries. One documentary is about poverty, another one about gardening, another one about cooking, and another one has a successful story. And the dependent variable is a happiness rating, which it's obtained by asking participants to rate their level of happiness in a scale from -100 to 100. Okay, so we are going to use JASP to do the descriptive, to get the descriptive day analysis. So we've got here, so you go to File and Open, and then you go to Computer and then Browse. I've got a recent folder here, so it's there, and Documentary Happiness is my file, and I got it open before, so let me just close that. So here we've got participant number, the values of documentary variable, and the values of happiness. So for participants 1 to 100 were exposed to the poverty documentary, 101 to 200 were exposed to gardening, 201 to 300 to cooking, and 301 to 400 to success. And here are the scores for happiness for each participant. Okay, so let's do descriptive statistics, and we put the dependent variable on top, happiness, and split by documentary. So basically we'll provide, so here without splitting, it gives us the mean happiness on the whole sample of 400 participants, standard deviation, minimum, maximum, and if we go to statistics, we can add more statistics that we are interested in. So, but we want to split by documentary. So basically, JASP will split the values of happiness in using the values of documentary. So we want to do this because we want for cooking, for gardening, for poverty, and for success the statistics, not very interested in the whole 400 values. So here we've got the mean, standard deviation, minimum, maximum. If we go to statistics, we can add median, mode, sum, percentiles, variance, etc., etc. And we can go to plots and display distribution plots, shows distributions. So in cooking and gardening, the range is very narrow. The values are within a very narrow range. So the bins for the histogram are each value, whereas in for poverty and success there is a higher range. So the bins include several values. Okay, so we can also use the display the box plots, and we have them here. So for cooking, gardening, poverty and success, these are the means for happiness, and I'll prefer the violin element, but obviously together they don't go very well, so I eliminate the box plot, and then the jitter element adds the data. Doesn't look very good. Let me see if by going to the right corner and moving, increasing the size, it gets better. Not much better. Let's try something. Okay, so you can get better than this. So if this doesn't work, you can put the jitter element is the data with the box plot, or just the box plot, or just the violin plot. It's your choice. Okay, so this is the descriptives, and that's the one I did with R. Basically is showing the raw data, the violin plot, and the mean is the green lines. Okay, so this is the descriptive statistics. The mean for each category, mean happiness, is shown here with the corresponding standard deviations. Okay, so let's start with parameter estimation. First the traditional or frequentist approach, then the Bayesian approach, and then resampling. So for the traditional parameter estimation approach, we are going to use JASP, and we are going to use the ANOVA, but we are not going to actually do the ANOVA. Okay, so I show you. Okay, so we are in descriptive, so we just move to ANOVA and ANOVA again. The dependent variable is happiness. The fixed factors are given by documentary, only one fixed factor. Now what we want to do is we are going to ignore this for a while. We are going to come back to this when we do null hypothesis statistical significance testing, but now we are doing parameter estimation. So we want to estimate the mean of each category and the differences of means among all the categories. Okay, so for that we will go to post hoc tests, and documentary goes to that side, sorry. So basically here we've got the mean difference. And if we go to additional options, which is a bit lower, sorry about that. So we got here additional options. So we have marginal means. Marginal means, we put documentary over there as well. So we've got here the means for each category of documentary, and we've got the mean differences. So we've got 4 means and 6 mean differences. Okay, so basically, for the means, we just calculate the confidence interval, the lower bound and the upper bound of the confidence interval. And here we've got that the standard error is the same for each category. Why is this? Because we are under the ANOVA analysis. So in the ANOVA analysis, there is an assumption that the populations that these 4 categories come from, so the values of happiness from these 4 categories come from, have the same standard deviation. So it could be different means, but same standard deviation. So that's why the standard error that is reported here is reported, is calculated or estimated based on using the 4 standard deviations. That's why we have the same for each category. Now, that is something that there is an option to do it differently. If we want to calculate, do the estimation of cooking only, and we don't make the assumption that the population of cooking values has the same standard deviation of the others, then we don't use the other standard deviations to estimate the standard error, or the standard deviation of the population, and in turn the standard error. So this estimation varies according to what values we use to make the estimation of the standard deviation of the population. So this is certainly a normal way of doing it. Within the ANOVA analysis, then we do this. But if you do it, if you use a t-test and you compare 2 of these categories and you ignore the other data, then the standard error will be different. And this is not wrong. It is, you have to make decisions on how to make estimations, and you have to report those decisions. So people who read the article know what you've done, and if they are not happy with that, they will tell you, or they will ignore your results. If they agree with what you've done, then they will take your results more seriously. There are no just one way of doing things. There are different ways of doing things. The important thing is that you justify it and that you show you're transparent of what you've done, and not that you do the things in order to fit your theories or your expectations. Okay, so basically this is the case here. We are going to use this standard error, and in this case just calculates the standard, the confidence interval, 95% confidence interval. Now for mean differences, for some reason it produces the mean difference and the standard error, but it doesn't produce the 95% confidence interval, but you easily calculate it by hand by multiplying the standard error for 1.96, and you produce the confidence interval. Okay, so let's return to the slides, and here is the marginal means estimated with confidence interval, and in this case the way you calculate the confidence intervals is this way. Okay, so now let's move to Bayesian parameter estimation, and in this case I can obviously do it with R, but there is a website that this particular analysis can do it for you. And what this website does, and I'm going to go directly, is to do analogous to the traditional t-test, but in a Bayesian way. So they actually is called BEST. Bayesian estimation supersedes the t-test. And what here, in order to estimate the means and the mean differences, you do it by pairs. So it's a completely different approach that the one I use for the traditional method, in which it uses the 4 groups. Here it uses just 2 groups at a time. Okay, so I'm going to show you how to do it. So what you have to do first is to open the file in Excel or equivalent. So here is the file. And then I'm going to cut and paste the values of happiness for poverty in this case. Okay, hold on a bit. So we've got the 100 values of poverty. So I just copy and Control C, and then data group 1, just Control V, and just in case, delete this space at the end. I don't think it will be any problem, but just in case, delete it. And then this, I copy and paste the 100 values of gardening. So I'm going to do 2 things. I'm going to estimate the mean of gardening, the mean of poverty, and the difference between poverty and gardening. Okay, so Control C, and then go to the website, and I can eliminate first, and then Control V, and get rid. And then you just do click to start, and the software starts working. Okay, so you see that it's working over there, and it's doing this. This is all good, and it is doing simulations. It's more Monte Carlo, Markov chain Monte Carlo simulations, and that's the typical Bayesian parameter estimation. And then after a while it stops, and it gives you a distribution of differences of means. Here is poverty minus gardening. So, and it gives you the 95 confidence interval. Here, so this analysis is based on a paper by Krushki, and he calls this high density interval to differentiate from the 95% confidence interval, which is used in the traditional approach, but to me it is, in Bayesian case, is a confidence interval. Anyway, it's just a way of calling the same thing. So the interval is between minus 56.3 and minus 53.2, and the mean of the distribution minus 54.8. So that's the estimation of the difference between poverty and gardening. Okay, so but there are more things. We've got here the density for the mean of group 1, which was poverty. So here the mean of this distribution is minus 49.9, and the 95% confidence interval minus 51.3 to minus 48.4. And ignore these ones because it's an estimation of the standard deviation. We may be interested, but not now. And this is the density for the mean of group 2, which is gardening, and the mean is the mean of that distribution is 4.9, and the interval 4.45 to 5.34. So that's the estimation of the mean. So we estimated the mean of two of the groups and the difference. So basically what we have to do is to do the same for all the comparisons, the 6 comparisons that we want to do, and we produce the estimation. Now it's easy to do, doesn't require knowledge of software. Okay, so just one technical thing in terms of what the software does. Well, it uses this statistical model in which the values of happiness, y here, follow a t distribution, and that t distribution has a location parameter, which is one location parameter for each group, one dispersion parameter or sigma, one per group, and this is the Greek letter nu. And I'm not going to explain this because it becomes very technical, but basically it's the same as the idea of a normal distribution with some small differences. So the mu 1 will tell you where this distribution should shift, because if it is 6, then the distribution will be around 6. If it is 100, it will be around 100, etc., etc. And the dispersion is how flat this distribution is. So if you have a huge sigma, then this distribution will be very flat. If you have a very small, it will be very peaky. Okay, so basically based on those priors, sorry, this is not the priors, this is the probability of the data as shown here. So based on that that probability distribution, we can obtain how likely is to observe each of the 100 values we observed in each of the groups. So basically we are going to estimate the best mu, the best sigma, and the best nu, to obtain the as high likelihood as possible. And the parameters have the mu's, okay, which is 1 per group, and the sigma have prior distributions, and these are uninformative. So basically Krushki decided that he prefers not to use prior knowledge, just a distribution in which the probability for each possible value is more or less the same. So based on that, it provides a posterior distribution of mu. So it started with a very flat normal distribution, which is almost like a uniform distribution, and then it produces a posterior distribution of the mu, which is the one I showed you. So here, and the mu, that's the posterior distribution. So we started with a flat prior, and now a posterior which is very concentrated around values minus 50. So, and then it calculates the difference between the two means, and that's that distribution. Okay, so basically that's what the software does. Final part of this video is parameter estimation with resampling. And what we do is from the 100 values of poverties and 100 values of success, 100 values of cooking, 100 values of gardening. We resample, we obtain one value randomly, we write down that value, we put it back, and we do that again and again and again in order to produce a new sample of 100 values. And then we do two things. We calculate the means of these 4 new samples, and then we calculate the difference between those means. So we calculate the 4 means and the 6 mean differences, and we write down those values, and then we do the whole process again. We do another new sample for each of the groups, and then we calculate the mean for each of the groups and the 6 mean differences, and we write down those values, and we do that 5,000 times. So we've got 5,000 means and for each category, and 5,000 means for each mean differences, and we create distributions based on that. So here I just show you the example of poverty, success, and the mean difference between poverty and success. So here values of poverty and are around -50. The values of success are around 49, and the mean difference values are around -98. Okay.